By way of transformations, I want to demonstrate and show you how you can get to the standard form of a quadratic function. And as you notice, I have a basic form here. X squared is our basic parabola, or quadratic, and I have a coefficient out front of it. And if you remember in transformations, you remember if a was positive, you remember the graph was positive or it opened up. If a was negative, it opened down. Well, we also remember that we can shift graphs left and right or up and down. In order to shift a graph left, let's start a new function, g of x. I had another component in there that I could shift it left or right. And for right now, we're going to shift it h units. We're going to designate the letter h to be our horizontal shifting. And so this tells me that it is shifted to the right that many units. And then I can also shift the graph up or down by adding a vertical component at the end, some constant over here, which we'll designate as k. So by understanding some of the aspects of transformation that we've already practiced and learned, we can transform and see the original graph can be transformed into a quadratic function that can lie anywhere on the coordinate plane. So my original function, x squared, parabola, shifted left or right depending on the h, and also shifted horizontally, and also shifted vertically depending on the constant at the end, k. And a couple of things we can also take note here is that this is true if a does not equal 0. And we also determine that h and k, the point h and k, well, that's the vertex of our new parabola. So when we see a quadratic in standard form, we can look at h and k, or the placeholders that determine its horizontal shift and its vertical shift. We can look at those and determine the vertex of a parabola, which has become very useful many times.